Mars had oceans. Groundbreaking news from 400 million kilometers away. Scientists are electrified. New data from China's Zhurong rover suggests Mars was once a blue world, not just a dusty red planet. We're talking about real shorelines and waves. Mars may have looked a lot like Earth. The Zhurong rover has uncovered evidence of a coastline in Utopia Planitia, a vast Martian plain. This isn't just another rock, it's a geological storybook revealing water, wind, and waves from billions of years ago. Suddenly, Mars shifts from a forever dead planet to one with a dynamic, possibly living past. The implications are huge. This changes our understanding of planetary evolution and the search for life. For decades, we found hints: frozen water, dried riverbeds, water-formed minerals. But a global ocean? That was just a theory, until now. Zhurong's findings move us from maybe to very likely. This isn't just geology, it's astrobiology. Where there was an ocean, there could have been life. Get ready to journey back in time to a Mars you've never imagined. We'll explore what Zhurong found, why it matters, and what it means for the future of space exploration. The red planet is starting to look a lot more blue, and the universe just got more interesting. Let's dive in. Imagine Mars 3 billion years ago. You're standing on the shores of Utopia Planitia, not a cold, dusty basin, but a place with a cool breeze and a hazy blue sky. Before you, a vast ocean, waves lapping against volcanic sand and red pebbles. The sun is dimmer than Earth's, but it still warms the surface. This is the ancient Mars science is revealing. No trees, no grass, just rock, sand, and water. The silence is broken only by waves and wind. Could there have been life in that water? Microbial mats clinging to rocks? We don't know, but for the first time it feels possible. This vision is built on decades of clues, deltas, river valleys, and minerals that form in water. But seeing a shoreline, the meeting of land and sea, was the missing piece. This is where the chemistry of life could have started. Standing on this ancient beach, we're witnesses to a world of possibilities. The ocean is gone, but its memory is preserved in the rocks. Thanks to Zhurong, we're finally learning to read that memory. The ghost of this ocean is calling us to dig deeper. Why is water so important? On Earth, wherever there's water, there's life. Water is the universal solvent. It dissolves nutrients and enables the chemistry of life. Without water, life as we know it can't exist. Life on Earth began in water, and it's still tied to it. That's why, in the search for life elsewhere, we follow the water. Finding evidence of a past ocean on Mars is like a neon sign. Life could have started here. For a significant period, Mars had the primary requirement for habitability. Space agencies obsess over Mars's watery past. Every mission is, in some way, a water-seeking mission. We look for water as vapor, ice, hydrated minerals, and now as the fingerprints of ancient oceans. Each discovery adds to the puzzle of Martian habitability. The discovery of a shoreline isn't just geology, it's biology. Mars is now a prime candidate in our search for extraterrestrial life. The question, did life ever show up to the party? The idea of water on Mars isn't new. In the 19th century, astronomers thought they saw canals, sparking science fiction about Martians. But early spacecraft showed a cratered dead world, and the dream of a wet Mars faded. Then, Mariner 9 in 1971 revealed enormous dried-up river valleys, clear evidence of flowing liquid. Viking orbiters mapped even more features, but some scientists argued these were from brief floods, not long-lasting water. The debate: was Mars briefly wet, or persistently warm and wet? 21st century missions mapped minerals that form in water, and rovers like Spirit, Opportunity, and Curiosity found rocks soaked in water and ancient stream beds. The evidence for lakes and rivers became undeniable, but a true ocean remained controversial. Utopia Planitia, a vast lowland, was suspected as an ancient seabed, but the evidence was ambiguous. Proposed shorelines were uneven, and skeptics pointed to volcanic or other geological processes. We had circumstantial evidence, but not the smoking gun. What we needed was a ground-level view, a geologist on the scene. That's what we finally got. Zhurong landed in the right place, with the right tools, and it changed everything. On May 15, 2021, China's Zhurong rover landed on Mars, marking a new era in planetary exploration. Only the US and Soviet Union had operated rovers on Mars before. China became a major player. Zhurong touched down in Utopia Planitia, a suspected ancient seabed. The mission's goal: study local geology and search for signs of water ice. Utopia. Planitia's smoothness made it a prime candidate for an ancient ocean floor. Zhurong was part of the Tianwen-1 mission, orbiter, lander, and rover working together. The rover was equipped to analyze soil, study the magnetic field, survey climate, and probe for evidence of past water. Its landing was a strategic move to tackle one of planetary science's biggest questions. Zhurong wasn't just another rover, it was a symbol of a new global age of discovery. Zhurong is a six-wheeled solar-powered robot with a unique set of instruments. Its ground-penetrating radar gives it geological X-ray vision, mapping layers beneath the surface. It also has a multispectral camera, a laser for analyzing rock chemistry, a magnetometer, and a weather station. Zhurong traveled over 1.9 kilometers, far exceeding its expected lifespan. It sent back high-resolution images and data, giving us our first ground-level view of Utopia Planitia. Its journey was carefully planned across different terrains and sample subsurface geology. The key: Zhurong systematically probed the structure of a suspected ocean basin. It mapped the architecture of the ground, revealing a history book written in layers. This unique capability led directly to its unbelievable discovery. Zhurong's radar data changed our view of Mars forever. What did Zhurong find? Its radar mapped layers beneath Utopia Planitia, layers sloped and angled in a way geologists call onlap, a classic sign of a shoreline. These layers draped over buried hills and craters, thickening in low areas and thinning uphill, just like on Earth's coasts. The pattern matches sedimentary structures created by rising and falling sea levels. Zhurong's radar revealed evidence of backwash, sediments carried by waves or currents, pointing to a large standing body of water. Scientists compared these patterns to Earth's coastlines. The resemblance was striking. This wasn't a localized fluke. The radar saw these features over a long distance. The findings suggest Utopia Planitia was shaped by a large, long-lasting ocean, or sea. Zhurong didn't just find a wet rock, it found the structure of an entire coastal environment. The ghost of a Martian beach, buried by time, was finally revealed. This is the smoking gun we've been searching for. The discovery of a Martian ocean revives a big puzzle, the faint young sun paradox. Billions of years ago, the sun was dimmer. Mars should have been frozen. How did it stay warm enough for oceans? One theory: Mars had a thick, greenhouse gas-rich atmosphere that trapped heat. Over time, solar wind stripped this atmosphere away, leaving Mars cold and dry. Another idea: periodic volcanic eruptions or impacts caused brief warm spells. Zhurong's shoreline evidence suggests a stable, long-lasting ocean, supporting the thick atmosphere theory. The debate continues, but Zhurong's data pushes us to rethink Mars's ancient climate. If Mars had an ocean, where did the water go? Without a magnetic field, solar winds stripped water molecules from the atmosphere. Hydrogen lost to space. The rest likely froze underground, forming a vast layer of permafrost beneath the surface. The ancient ocean isn't gone, it's transformed. Some lost to space, some locked as ice. The big question: was there enough time for life to arise? If so, could traces remain underground? Future missions may need to drill deep, searching for life in subsurface ice or brine. Zhurong's discovery gives us a prime location to start looking. The story of Mars is far from over. This is just the beginning. Future missions will target these ancient plains, searching for answers. The truth is out there, buried in the red dust, and we're getting closer every day.